Good morning, everybody. We're here to look at the opening section of our homework packet, graphing linear inequalities. This is kind of a detour from the normal stuff that we do because one of the things that I saw in our last quiz is just we really need to be able to graph lines. And so I'm going to take a moment. And the whole point of this is just to make sure that you guys drill this skill. I don't typically like to do these endless drills, but our performance shows that we need to kind of tighten this up a little bit. So here's where it comes in. We'll start with this first one where it's y is less than negative 1/5 x plus 1. And what I want you guys to notice here is that even though this is not an equal sign, we are going to graph it as though it were. It's going to behave very similarly to an equal sign. So that means this is going to be very similar to y equals mx plus b. So I know that 1 is my b, and my b is my y-intercept. And we need to have this absolutely memorized at this point. So if the b is the y-intercept, that's where it crosses the y-axis. It crosses the y-axis at 1, so I know that that is a point on the line. Now I need to find another point, and I can do that by looking at my slope, which in this case is negative 1/5. So negative 1/5, so negative 1/5 is the same as negative 1/5 or 1/5 because of the way that multiplication works and division works. That negative doesn't matter where it is. So when I look at this, what I'm building is something that we call a slope triangle. Now slope, as we all know, is rise over run. So my rise is 1, my run is 5, but I have to be going negative. So that means I can rise negative 1, which means I go down 1, and then I can run 5, So here the negative is accounted for by going down, and the 5 is accounted for by going this way. Or I could do it the other way. I could do it this way, where I rise 1, but then I run negative 5. So that means I go back negative 5 to right here. Either way works, and you can see that it still creates a consistent line. Penultimately, next to last, I need to draw in my line. And there appears to be some confusion about when to do a solid line and when to do a dashed line. A solid line will be any time we have less than or equal to or greater than or equal to. If it has the line underneath our inequality symbol, that means it's solid. The dashed line is when we don't have that. We see that we don't have that. We have less than. So that means we are going to be doing a dashed line. I'm doing mine kind of sloppy just to get it done quickly, but yet you can see here how that works. So I have my dashed line. Now, finally, I need to figure out which side of the equation I shade on. Well, when I look at this, I see that y is less than, and so whenever I see y is less than, that means I want to go down on my y. So from where my y-axis is, from my b, I can see that the numbers get smaller here, so I would shade that way. But sometimes it's not that easy. Sometimes you can't tell by looking at it. And so one of the things we like to do is a test point. So the easiest test point to do is 0, 0. That's the origin. So what we can do is we can take 0, 0, plug it into the equation, or the inequality, and see if it's true. If it's true, then we shade that side. If it's not true, we shade the other side. So we have 0 is less than negative 1/5 times 0 plus 1. 0 is less than, well, this is 0 plus 1. 0 is less than 1. Is 0 less than 1? Yes, it is. So I know that this side is true, therefore I know I shade this side. Okay. Now, there's only 2 equations on this packet that use y equals mx plus b, because one of the other skills that we absolutely need to have mastered before we move on with our algebra careers is being able to graph from standard form. So that's why a lot of this is in standard form. This means there's going to be a lot of extra steps, but we absolutely have to be able to do this. So when I look at this, there are 2 ways that we can solve this equation. The first way is to solve it from standard form. So from standard form, all we do is we find our zeros, find our intercepts. And we do that. If I plug x equals 0 into the equation, I'll get my y-intercept. Okay? So if I do that, I have 7 times 0 minus 3y is less than or equal to negative 6. This is 0, so negative 3y is less than or equal to negative 6. I have to divide by negative 3, divide by negative 3. Y is, oops, I divided by a negative number, so I switch my sign, greater than or equal to, and then negative 6 divided by negative 3 is going to be a positive 2. So I know that I'm at positive 2 as my y-intercept. That is one of my points, 2, the point 0, 2. I now do the exact same thing, except this time I plug in 0 for y, and this will give me my x-intercept. Okay, so when I do that, I have 7x minus 3 times 0 is less than or equal to negative 6. So I have 7x is less than or equal to negative 6. So I have x is less than or equal to negative 6/7. Oof, isn't that an ugly number? So I know that negative 6/7, it's almost negative 1. So it's going to cross around here. Okay. I know it's going to be a solid line. And now I need to figure out what side I shade on. So again, I'm going to do the test point. Okay, I'm going to do the test point. So when I plug in 0, 0 here, and this is where plugging in 0, 0 makes it super easy on the standard form. So the shade, I plug in 7 times 0 minus 3 times 0, and is that less than or equal to negative 6? Right? Well, 0 minus 0 is less than or equal to negative 6. You see how these just both become 0? In fact, that whole left side of the equation becomes 0. So it's super easy to figure out what side it is. Is negative 6 less, or 0 less than negative 6? No, 0 is a greater number than negative 6. Right? Here's negative 6, here's 0. So I know that this is not part of the equation, therefore I shade this way. Okay? That's how we do it when we look at our intercepts when we go straight from standard form. But you can see we have one kind of weird issue here. Like, we ended up trying to find negative 6/7. That's a little bit confusing. And sometimes it's not exactly clear what we need to be doing. So another way that we can do this is by converting standard form into slope-intercept form. Okay? So when I do that, I have 3x plus y is greater than 5. And so I want this to look like, by the time I'm done, y equals mx plus b. So to do that, I have my y on the left side of the equation, but I have my x term on the left side of the equation, and I want that on the right side. So I have to move it by subtracting 3x from both sides of the equation. You have to balance your equations. I've seen far too many students just take the 3x and just write 3x on the other side of the equation. That's not how this works. We're subtracting it from the left, therefore we subtract it from the right. So when this becomes 0 plus y is greater than a negative 3x plus 5. Thus, 0 plus anything, we can ignore that, so y is greater than negative 3x plus 5. It is now in y equals mx plus b form. We can now graph it. B is our y-intercept, so all I have to do is find 5 on our y-axis, that's 1 point. Our slope is negative 3. That's the same as negative 3 over 1. So I'm going to go down 3 over 1, down 3 over 1 like so. And then I see that my sign is greater than. It doesn't have the or equals to. And so referring back here, when it's greater than with no or equals to, that means we do our lines, doop, 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 like so. We dash them. Okay? And now I need to figure out what side I shade. It's where y is greater. Well, this is 5, 6, so this is the greater side. I shade like that. But again, if you wanted to, you could plug in 0, 0 as a test point to see if it works. Now, when we plug in 0 as a test point, this becomes 0, this becomes 0, so the whole left side becomes 0. Is 0 greater than 5? No. So we know that this is not the side that we shade. All right, guys. That's going to be your homework for today. You're going to grind that out. We absolutely need to be able to do these sorts of problems to continue. So focus on it, and we'll come back to our regular schedule tomorrow.